So hey everyone, welcome back to another video, and today in this video we are going to discuss our first sorting algorithm, that is bubble sort. So in this video we will be going to discuss why it is named as bubble sort, what is bubble sort, its algorithm in C++, optimized approach of bubble sort, and time complexity and space complexity. So without any further delay, let's get started. But before starting the video, please like, share and subscribe to my channel to keep motivating me for bringing more such content. So let's get started. So let's understand why it is named as bubble sort. Let us consider an array 4, 5, 3, 1, 2. Now in this array, in the bubble sort, it happens like whatever is a maximum element in the one iteration, whatever is the maximum element, that is 5 will come at the end. Now remaining are 4, 3, 1, 2. Now second maximum element 4 will come at the end, remaining are 3, 1, 2. Now third maximum element 3 will come at the end, remaining are 1, 2. Now fourth maximum element, that is 2, and remaining is 1. So in this way we can see our array is sorted. Now what is happening here, like every time maximum element from the portion, from n elements, maximum element is taken, pushed at the end. Similarly, now 4 elements, now out of 4 elements, maximum element is taken and pushed at the end. It's like the biggest bubble is going at the end, second biggest bubble is going at the end, third biggest bubble is going at the end. So that's why it is named as bubble sort. Now let's understand what is the algorithm and what is actually bubble sort. Bubble sort is the simplest sorting algorithm, as we have understood. Like every time we are taking out a maximum element and pushing it at the end. It happens by swapping the adjacent element. Now what happens in bubble sort? So for example, if we have an array, and in this array we have array I, and this is array I plus 1. Now if array I is greater than array I plus 1, so if ai is greater than ai plus 1, then we will swap. Otherwise, we will not swap. Now we will understand how swapping is helping to make the array sorted. But let's understand now that we are just swapping the elements, and that's how the bubble sort works, right? Now after every pass, maximum element goes till the end, as we have seen above. Like every time 5, 4, then 3, then 2, then 1. This is how the maximum element is going at the end. Now let's understand the algorithm, how swapping is helping us to make the maximum element to go till the end. Let's understand. So these are the number of iterations I have wrote. This is first iteration, second iteration, third iteration, fourth iteration. So this is how it will work. So let's go in first iteration. In the first iteration, what we will do? Simply, we will check if array is greater than array plus 1, swap. Otherwise, don't swap. So let's see. 6 is greater than 4, swap. 6 is less than 8, don't swap. 8 is greater than 1, swap. 8 is greater than 2, swap. Now finally we got the array 4, 6, 1, 2, 8. Now we can see that this point is at correct position. 8 should be at last, and it is at last. Because by swapping the element, since 8 is the greatest, so always it will find any smaller. It will always push and end by swapping. 8 will find 1 as smaller, it will say let's swap. 1, 8. Similarly, 8 will say 2 is smaller, let's swap. So this is how maximum element always is going at the end. So now what is our focus area now left? From the n elements, our focus area shifted to n minus 1 because it's already at its correct position. So we don't need to think about that. So let's see this point 4, 6, 1 and 2. Now out of these, let's apply the bubble sort in the second iteration here, right? So 4 is less than 6, don't swap. 6 is greater than 1, let's swap. 6 is greater than 2, let's swap. So in the next iteration, we can see 4, 1, 2, 6, 8. 6 and 8 are at their correct position. So now we don't need to think about that. Focus area from n to n minus 1 now shifted to n minus 2 elements. Now 4, 1, 2. 4 is greater than 1, let's swap. 4 is greater than 2, let's swap. Now we got the 1, 2, 4, 6, 8. Now focus area shifted to only these two elements. Now it will always find 1 is less than 2, no? So let's go ahead. So yes. So finally we got the sorted array, that is 1 is less than 2, 2 is less than 4 is less than 6 is less than 8. So you see how swapping is helping us. Every time when we take greatest and smallest, greater will find smaller. So let smaller go before and greater will come after that. So in this is how greatest element will go at the end. Then next greatest element will go at the end. This is how the bubble sort work. So what are the number of iterations we have taken here? Number of iterations are n minus 1. Why? Because here 1 2. Now single element is left. So obviously it will not swap with someone. These are already sorted. We will not think about that. But this is a single element. Since this is a single element, obviously there is no one to swap with it. So we will say like no need to swap. So number of iterations are 4. If we have 5 elements, the number of iterations are n minus 1. That is 5 minus 1. That is 4. Now in every iteration, we are going for n elements, n minus 1, then n minus 2, then n minus 3, and so on. So this is how bubble sort algorithm works. So let's jump to the how coding part works. So what we have seen, like we have n minus 1 iterations. So we will run a for loop for iterations. So this is a for loop for iterations. Now in the nested for loop, what we will do? We will go for swapping the elements. But let's see what we were doing. n minus 1, then n minus 2, then n minus 3. So this is how we were going. So how? In the 0th iteration, it was n elements. In the 1th iteration, it was n minus 1 elements. So you can see n minus 0, n minus 1. In the second iteration, if we consider zero-based indexing, it is n minus 2 elements. In the third iteration, if this is 3, by the zero-based indexing, it is n minus 3, right? So we can understand like every time in every iteration, number of elements are reducing. So that's why the nested loop for swapping the elements will go from 0 to n minus 1 minus I actually. And whenever if we find array j is greater than array j plus 1, then we will swap, otherwise we will not swap, right? So this is how bubble sort algorithm works. So let's go to the GFG and let's code it up and let's see whether it's working fine. Now here we have a for loop for the number of iterations n minus 1, and in the every for loop we have n minus 1 minus I, because number of elements from n to n minus 1 to n minus 2 elements are reducing one by one. So if array j is greater than array j plus 1, so what we will do? We will just swap the elements, right? So let's try to compile and run the code and check whether it's working fine. So let's submit the code. So yes, it's totally working fine. So what is the time complexity and space complexity? Let's discuss. Since we have two for loops, one is this, one is this. So big of n cross n. Like if we have n elements and n minus 1, but we can consider n and n only because these are just constants. So these are, and they are n times, because n minus 1 iteration we can consider n times. If we remove the constant, it's like big O of n square. So we'll say time complexity is big O of n square. Space complexity is big O of n. Why? Because we are not taking any extra space. We are just swapping the elements. So yes, that is a time complexity and space complexity. So can we further optimize this bubble sort algorithm? Yes, we can optimize. But how? Let's visualize some example and let's understand. Let's visualize first, then we will get the intuition like how we can optimize it, right? So let's visualize. We have 6, 8, 1, 2, 4. Let's apply that same bubble sort algorithm. 6 is less than 8, don't swap. 8 is greater than 1, swap. 8 is greater than 2, swap. 8 is greater than 4, swap. So finally it will be 6, 1, 2, 4, 8. Now focus area shifted to these elements. 6 is greater than 1, swap. 6 is greater than 2, swap. 6 is greater than 4, swap. Finally it is 1, 2, 4, 6, 8. So now focus area shifted to these three elements. Now 1 is less than 2, don't swap. 2 is less than 4, don't swap. 1, 2, 4, 6, 8. Focus area shifted to 1 and 2. 1 is less than 2, don't swap. So now we will again copy it. So finally we got the sorted array. So have we observed something? Yes. We observe one thing, that array is same for these 4 times. So we are just doing this redundant thing. Actually we can optimize this. How? Like why we are swapping? we are only swapping to get the maximum element to go till the end. But if swapping is not taking place, what we can observe from that? If no swapping is occurring, array is always sorted. If no swapping is occurring, array is always sorted. So that means we can understand if any time swapping in any iteration, in first, second, third, or any iteration, if the swapping is not there, then we can consider that array is sorted and just return or break from here. No need to go ahead, right? So this is the optimization. So let's jump to the editor and write this optimized approach. So we need to optimize just one thing here. So in every iteration, we have a flag. Let's say it's a true for now. And if anytime swapping is occurring, flag is false. So if we are finding flag as true, then why we are going in next iteration? Just return from here. Obviously, why? Because if there is no swapping, then that means this is redundant. This is not useful for us, right? So that's why we will return from here if flag remain as true as it is. So let's try to compile and run this optimized approach and check whether it's working fine. Yes, let's submit the approach. So it's totally working fine. So let's jump to time complexity and space complexity of this optimized approach. So obviously we are optimize a bubble sort, so it should have optimized some time or space. Space is obviously big of 1. There is no optimization in that. But how about time? In the worst case, time is still n square, because if array is like 8, 6, 4, 2, 1, then in every iteration we are going to swap. So if we find this, it will always swap. But in the best case, what can happen? If whole array is sorted 1, 2, 4, 6, 8. So obviously we are not going to swap here. One will find 2, okay, 2, 4, 4, 6, 6, 8. So no one will swap. So that means we will return from here. So in the best case, time complexity can be n, right? Because we are not going in any more iteration. We are just returning from the first iteration only, right? But in the worst case, if all elements are not sorted, we will swap in every iteration. It can be n square. So we have optimized that. In the best case, we have n, and the worst case, still it is n square. So this was all about optimized approach. So let's understand the advantages and disadvantages of bubble sort. So advantages of bubble sort are: bubble sort is easy to understand and implement. It does not require additional memory space because 1. It is stable sorting algorithm. That means if we have, let's say, 2, 1, consider we have 2, 1. This is first one, this is second one. Now let's say these 2, 1 are swapped. So what they will be? Second well will come at first and first well will come at second. So obviously we are changing the relative order of the elements. Like if the first one is before and second one is after, they should not swap. Like they can swap, but if they are swapping, that means it's not a stable algorithm. Stable means, for example, if we have 1, 2, 1, 2, then if the first one is before and second one is after, then here also first one is before, second one is after. It should not be like this one should come before, right? This is stable sorting algorithm. So we will discuss about in further videos, but in minor thing we can understand that whenever relative order of same elements change, that means unstable. But if they do not change, it's stable, and that's why bubble sort is stable sorting algorithm. Now disadvantages are, it has time complexity big of n square, which make it slow for very large. That is it. Obviously, big of n square is very big time complexity. We are going to optimize in further sorting algorithm that it will become bigger of n log n, right? And bubble sort is a comparison based sorting algorithm, which means require comparison operator, and obviously it can reduce efficiency because we are going to compare for every 2 elements, right? So this was all about bubble sort algorithm. So if you like the video, please like, share and subscribe to my channel for keep motivating me for bringing more such content. Thank you and have a nice day.